Welcome to our mini lesson on binary addition. When we talk about binary addition, there are four possible combinations. First, 0 plus 0 equals 0. This should be pretty self-explanatory as we're adding two zeros together. The second combination, 1 plus 0 or 0 plus 1, gives us 1. In binary, as in decimal, adding 0 to any number doesn't change its value. The final combination, 1 plus 1, is where things get a bit more interesting. Instead of resulting in 2 as it would in decimal, in binary we write this as 1, 0. So when we add 1 plus 1, we get a two-digit binary number 1, 0, which represents 2 in our decimal system. Moving on to more complicated binary additions, the process is similar to how we add numbers in our everyday decimal system. We simply add each corresponding pair of bits, moving from right to left, just like we do when adding decimal numbers. Let's try adding these two binary sequences which you're seeing on this slide, 100000110 and 1111101. Here we're adding each pair of bits starting from the right. We carry the 1 to the next higher bit only when the sum in the current bit equals or exceeds 2. We do this just like carrying over in decimal addition when the sum exceeds 9. We start from the rightmost bit, where 0 plus 1 gives us 1. Moving one bit to the left, 1 plus 0 results in 1. Then, 1 plus 1 gives us 1, 0, but we can only place the rightmost 0 in the current position and carry over the 1 to the next bit. For the next 3 bits, we add the carried 1 to the pair, each yielding a 1, 0. Hence we keep placing zeros and carrying over 1s. Finally, for the two leftmost bits, we add the carried 1 to 1 plus 1 to get 3, which is 1, 1 in binary. Again, carrying the left 1 and placing the right 1, but in the very last bit, there is nowhere to carry 2. In binary addition, when we add binary numbers of the same length, say n bits, we usually expect the result also to fit within n bits. But sometimes, the result might require more than n bits, resulting in what we call an overflow. It's like trying to fit 10 apples into a bag that can only hold 9. No matter how you arrange them, there are just too many apples. So in binary, if the result can't fit into the allocated number of bits, it overflows. A common misconception is to always associate the carry extending the most significant bit automatically with overflow. It is more useful to remember the metaphor of an apple not fitting into a bag. Overflow occurs when the result doesn't fit within the allocated bit capacity, not necessarily when there is a carry from the most significant bit. For example, when adding negative numbers, as we'll be seeing in the next few videos, we might have a carry extending the most significant bit. But this doesn't always result in an overflow. Let's delve into another example to solidify our understanding of binary addition. For this instance, we will be adding the following 8-bit binary numbers, 101000101 and 010100011. Let's break down this addition step by step, starting from the rightmost bit and moving towards the left. In the rightmost column, 1 plus 1 equals 1, 0. Here we place 0 and carry over the 1 to the next bit. Next, 0 plus 1 plus the carry from the previous bit gives us 1 plus 1, which is 1, 0. Again, we place 0 and carry over 1 to the next column. The third bit from the right involves adding 1 plus 0, plus our carry from the previous operation. This gives us another 1 plus 1, which equals 1, 0. Yet again, we place 0 and carry over 1. Next, we add 0 plus 0 plus the carry, resulting in 1 without any carry. The fifth bit from the right is 0 plus 1, giving us 1 without any carry. In the sixth position, 1 plus 0 results in 1, also with no carry over. Lastly, in the two leftmost columns, we have 0 plus 1 and 1 plus 0, both resulting in 1. Putting it all together, the result of our addition is 111111000. Here, the resulting binary number fits comfortably within the original 8 bits, so there's no overflow. Remember how I mentioned not to automatically associate the carry extending from the most significant bit with overflow? Well, that's generally true. However, in cases like this one, where we're dealing only with positive numbers, a carry extending from the most significant bit would indeed signal an overflow. As we haven't introduced negative numbers yet, we're always assuming that we're dealing with positive numbers in these examples.